We were asked to find the inverse of a logarithmic function. And we have two problems we're going to do here. The first thing we have to do in any inverse function or inverse problem is to switch x and y. So I'm going to start by switching those around and then solving for y. So I want to isolate the log before I do anything new. So I'm going to first add 5 to both sides, equals log base 4 of y plus 11. Now here's the new thing, right? To get rid of a log, I'm going to raise both sides to the base that matches the log. So these two things cancel out. Anything I do to the right side, I have to do to the left side though. So now I have 4 to the power of x plus 5. And now that log is gone, so it's just y plus 11. My last step here will be to subtract 11 from both sides, which will get my final inverse equation of 4 to the power of x plus 5 minus 11. Second one is going to have kind of one extra step here, but first step and second step are all the same. I'm switching x and y, so x equals 2 log base 9 of y minus 8 minus 6. I'm still going to isolate the log, so adding 6 to both sides. And then I need to get rid of that 2, so I'm going to divide both sides by 2 here. I'm just going to leave this as x plus 6 over 2. You could technically do like 1/2 times x plus 6, but I'm just going to leave it as is for now. And now that I've isolated the log, this is where the new thing comes into play. To get rid of this log, I raise both sides to the matching base. So I end up getting 9 to the power of x plus 6 over 2 equals y minus 8 because the log has now been canceled out. I add 8 to both sides. Gives me my final inverse here of 9 to the power of x plus 6 over 2 plus 8. That is how you find the inverse of a logarithmic function.